All right. I think I'm recording the right thing. Am I sharing my screen here? Can you guys see the Excalidraw?
Yep.
Okay, cool. All right. Yeah, so we're gonna do more recursion. As I mentioned, this is one of those conceptually novel things that I wouldn't, if you've never seen it before, I wouldn't expect you to just instantly grasp it. It can take a while. Took me a while to get, so that's fine. We're gonna go through a couple examples. Um, I think we'll do three example recursion functions that are going to get more and more complicated. So the first one, so what we'll want to do, let me make this a little larger. So what we want to do here is write a function that will take in a number, an integer as input, and return true if it's even, and false if it's odd. So let me just write this out. So the input, it's going to be a num, let's say an integer, and return going to return a Boolean. So some restrictions for this. One, the solution has to be recursive. And we can't use division. So that includes the modulo operator. Okay, so we have this problem, we have some restrictions. So the normal way we would solve this, of course, is to use the modulo operator and see, whatever the number is, mod, 1. If that is 0, then it's odd, otherwise it's even. We can't do that. So before we just start writing code, let's try and figure out how we can solve this problem without code. So let's start with a number. Let's start with a number 3. So how do I know if 3 is even or odd? Well, when you are thinking about problems recursively, what you need to do is, first off, think about what is the simplest possible trivial input you could have. So if I want to take in a number and know if it's even or odd, what is the simplest possible input I could have?
A modulus?
So in input, so in the input for the function, the parameter has to be an integer.
I would say 1 and 2, 1 or 2, like
Okay.
base case.
Right. Yeah. So what we're basically trying to do is figure out what the base case is. So the simplest input could be 1. So we know that 1 is odd. So if we know that 1 is odd, then if someone gives our function, someone passes a 1 into our function, we can just say, oh, it's odd. And what's the simplest case for an even number? An even number?
2.
Could be 2. Yeah, 0. I mean, I'm not a mathematician, so I'm not sure if 0 technically counts as an even number, but we'll say 0. So the simplest possible input could be a 0 or 1. So if it's a 0, I know for sure that it's even, and I can just return true. If it's a 1, I know for sure that it's odd, and I can just return odd. So we have those. We have that base case worked out. So I'm gonna just write that in for now. So def, I'll call this is even if num is 0, return true for the autocomplete, else if num is 1, return false. And then I'm not sure what's going to happen otherwise. So we can write some tests for this. So I'm going to create a test file. So even tests.py. I'm going to import unit test. And we'll talk about classes next week. So you're getting some exposure to some class stuff without having been formally taught it. So class, this is just how the unit test library works. Test even test case. And so here we're going to write some test methods. So test 0. 0 input, yeah. So self, and we're going to return, we're going to import this odd or even function from right here. So from odd or even, this is the file name, import, and this is the function name, which is going to be is even. And then we're going to call is even. And we're going to call it with 0, because that's what the test is. And we're going to do self.assert equal result is true. So someone tell me what this test is doing.
Evaluating that 0 returns true.
Yep. Yeah, exactly. So I'm testing one possible input that I could give to this function, and I want to make sure that this is true. So I can run this Python. There's a few ways to run unit tests. A unit test has some magic built into it, where it will automatically find your tests for you if you formatted them in the proper way. So you can run it Python-m unit test. Okay, so I ran zero tests here. So that's not what I was expecting. Must have done something. 0 is doesn't like the function name. Okay, I think I have to call this. I might have to call this test. So there's some naming conventions. Let me try renaming this. So test even. Okay. So yeah, the unit test library expects things to be named particular ways. So if you have a test file, it should start with test underscore, and the same with the individual test methods that you write. Okay. So another test I can write. So someone, why would I bother writing these tests before I've written the function?
So that when you make changes, you can just run it and see if you've broken something.
Yeah, exactly. So this is scaffolding. So I know whatever I do, like I know this has to be right. So if I end up writing a function and I do something, maybe I'm kind of running it as one-offs with different inputs, and I feel like, okay, so that it works with this input, but maybe not with the other one. This is a way of keeping track of everything that you know should be true about this function. And you can run it all at once, so you're not introducing regressions. Okay. Let's do one more. So we want to say if 2 is true. and 2, that should be true. I'm gonna run this again. And this time the test fails. Okay, so we're expecting it to fail because we haven't implemented anything else. So pass is just a convenience to allow you to kind of put a placeholder here, but it's just going to return none. Okay, so we know that the simplest possible case, which is our base case, is that a num is 0 or 1. So sometimes your base case is just one thing, sometimes it could be a few things. So in this case, our base case has kind of 2 subcases. All right, so now what do we need to do here?
Call is even again recursively and subtract num from it.
Okay.
From num.
Good. So one, we have to do something recursive, right? We have to recurse. Because if we don't, then we don't have a recursive function. And what happens if I just call return is even? So what happens if I do this?
You're gonna get stuck in a loop.
Okay. So let's try running this. I'll just go ahead and run the unit test. But we see recursion error, maximum recursion depth exceeded. So we have our base case and we're recursing, but we can't just naively recurse. We have to do what?
Subtract.
Yeah, so in more general terms, what we have to do is get this input closer to our base case. So in that case, in this, for this example, let's say we start with 3. Well, our base case is 0 or 1. So we need to get 3 closer to a 0 or a 1 somehow. So in this case, we're going to do that through subtraction. We can't use division. So we're going to use subtraction. So if we think about, okay, what do we have to subtract from this input every time we call it?
2.
Right. So we know that we're going to have to subtract 2. So I'll create a new variable here. So new num is num minus 2. All right, so I'm gonna pick on someone. Let's see who's got their camera off. Vincent, walk me through. So pass in 3 as new num and walk me through in detail everything that's going to happen if I call is even with 3.
So at the start, it's going to check for the base cases. That's not true. Then it's going to go into the else statement, the bottom one, and it's going to create a new variable equal to num minus 2, which is whatever you passed in. So in this case, 3. It's going to make it 1. Then it's going to pass it back into the function, and it's going to go back to the top, and it's going to stop on the base case of num equals 1, and then return false.
Okay. Good. So what happens if I do this?
It's not going to work.
Okay, so why won't? Can you walk me through what will happen if I take off the final return statement?
I cannot. I just know it just doesn't work because I've done this.
Okay. Can anyone else tell me if this will work? Why or why not?
I don't think it'll work because you have to return the function in a recursive call, but it might work.
Okay. So is this going to actually recurse?
I think it'll call, but I don't know that it will recurse.
Okay. All right, so let's try running our unit tests. Okay, so if we look at the output from the unit test, it says it ran 3 tests and we got .f. So what does .f mean?
I think it failed the third test.
Yes, and it also means that we passed the first 2. Right? So we passed the first 2 tests and failed the third one. So
Right,
why did
'cause-
we pass the first 2 tests and fail the third one?
Because the first 2 tests, you're just testing the base cases, so it's not gonna get to the else statement. So go to F for the 0, return
Uh-huh.
true, and then the elif for the 1 and return false. But then when you add in you bring in a 3, it's not gonna work properly because you don't have the return statement.
Okay, so what type is going to be returned for these 2 first tests, 0 and 1?
Booleans,
Booleans. And what type is going to be returned for this
an
third
integer,
test case?
an integer.
An integer. Okay. So if I look at the assertion error here, it says that none does not equal true. So I'm expecting this to be true. And this is actually what?
It's none or
It's
undefined.
none. It's none. So why is it none?
Essentially, it's returning nothing. It's returning no empty case because there's no return statement on the else.
Yes. So, well, so it maybe this is a philosophical question, but is this function returning anything?
And
If
no,
it's
it
0
essentially
or
returns
1,
nothing.
Yeah, so every function does actually return something. It just will return none. If you don't give it an explicit value to return, it will return none. So this function, if it hits this base case, the first item in the stack, the first time you call it, it's going to return none because you don't have any other return. But when it recurses, so if we call this with 3, we call it with 3. It goes, checks the base cases, no. Falls through to here, and it's going to return whatever we tell it to. In this case, we're not telling it to return anything. So it's going to return none, but it's still going to call is even again. So we're going to get a new item in the call stack. It's going to return is even with 1. And this function will actually hit and return false. So this, the second function call will actually return false. The problem is that the first function call is just going to return none no matter what. So you have broken the chain that connects all of the items in the call stack together. So that's why you return none. So this function, it actually works. It's just that you're getting the right answer, you're just throwing it away. That's why you have to return. So if I return this and I run it and the 3 tests pass. So I can I'll add 1 more test, but we could add several more tests for different cases. Let's do 5 is false. And you run this. Okay. So if these test cases are okay. If you want to be sure, I would add a few more, but it looks like this is working. So the basic structure of recursive functions, you need two parts. One is the base case, and the other part is the recursive case. The base case is going to be, it's going to feel stupid. It's going to feel like you're doing something trivial. Like if it's 0, then return true. If it's 1, return false. That seems kind of trivial, but that's what a base case should be. It should be the simplest possible version of the input. And the recursive case is just, I want to repeat some operation an unknown number of times. And each time I repeat the operation, I want to bring this input closer to one of the base cases. So the job of the recursive part of the function is to break down the problem in such a way that it brings it closer to the base case.
Can I ask you a question?
Yes.
So if you have like a problem where you're storing something in an array or a list and you're recursively doing something, do you do your tests on the return value or what's stored in the array?
Yeah, so that's a good question. So when you're writing tests, when you're testing a function, you can't really access what's inside of the function, right? So if I'm outside of this function here or in this other file, if I'm importing it wherever, I don't have direct access to, new num, for example. New num is inside this function scope. So from outside of the function scope, I can't just say, hey, what is new num? Because right here, for example, it doesn't exist in this outer scope. It only exists here in this function scope. So this is one reason why you want to write functions that are small and do one thing. Because if you have one huge function that does 30 things, your tests can't access any of those intermediate results. You can only test, I give it something, what does it return? And it's the same thing if your function does a side effect, right? If you have a function and it just prints something in the console, you don't have direct access to that information.
Chad, I got a real quick question on the test side of things. If you could show me test even.
Yeah.
Can you, all the way at the bottom, like the last lines 23 and 24?
Yes.
What exactly is that? I haven't seen that syntax before. I mean,
Yeah.
I know like when you do dir, you'll get that, but
Yeah, that's a good question. So this is something that you'll see often in Python. And it basically means that this if name equals main translates to, did you run the file directly? So if name is main, then I ran Python test even. So if I run this file directly, then evaluate this. So I can do the same thing here. So I'm going to copy this.
okay. By main, do we mean just the main function in this case, or the main file?
It's a Python thing, and it just means did this file get run directly? So
Okay.
So this is an internal Python thing.
Okay. Thank you very much.
All right. So if I run odd or even directly now, Python odd or even. It prints out high. Now, if I run the unit test, I'm importing odd or even. So let me run the unit test now. So high does not get printed here. Why doesn't it get printed? Because I didn't run this directly. I didn't run this file directly. So this will be false and this won't run.
So in essence, what you've written then is if we were to run the file directly, right? So the def is even file, then at the bottom it hits the if statement, it knows you ran it directly, and then it launches into the test.
In this case, yes. So
Okay.
if whatever file we specify when we run it, this is going to be true.
Okay.
So if we run odd or even directly, this will be true. If we run test even, this will be true, and this one won't.
Okay. I think I understand. Thank you very much.
So this kind of thing is used because typically, you know, in any real application, you're going to have lots and lots of files, and you're going to be importing stuff around. So you don't want to, you don't necessarily want to. Yeah, I don't want to go off on too much of a tangent, but this kind of exists for historical reasons, and it also exists because of the way that other languages do things. But basically, if you want to write some ad hoc tests for yourself here, for example, is print is even, so I can run and I can see, oh, it's false. Okay, so that's good. And then, so maybe as you're developing, you can do like an ad hoc test right here, and then you can actually run your real tests, and this won't run. Or if we're not talking about tests, we're talking about like the real application code. If we're really running the application code, we don't want to run this one. So that's why it exists. It basically allows you to, you know, run something under certain conditions.
One last question on this is
Yeah.
if you have an application that you have multiple tests for, will you generally just have one test file or multiple test files for each file?
It depends. So if you have a giant application with lots of folders and different files and stuff, a lot of times what you'll do is you'll have another separate folder that's like tests, and then you can put all of your tests, test files in that folder. And then if you use the Python-m unit test, there are also other unit test frameworks. So this one is built in, but there are third-party ones that you can install as well. But if you follow certain conventions and do this, it will automatically pick up your tests and run them. So you don't have to like run each individual test file.
I have one more question.
Sure.
Just looking at this, the is even function, would it break if you used a very large number because of how deep the call stack would get?
Yeah. So that's a great point. So let's try with 2003. And I'm going to run this directly. So this would be an example of like, okay, I just want to run like a real quick ad hoc test, for example. So if I do odd or even, where's odd or even? Did I lose that? There we go. And so in this case, we get maximum recursion depth. So other languages, like functional languages, for example, will have, you don't need to know this, but just as FYI, other languages that are kind of built for recursion will usually do something called tail call optimization. And tail call optimization basically is a compiler trick that will turn. So what someone tell me what the problem is here. What is a recursion error? What's the problem?
Run too many cycles, and in this case, looks like the maximum you could do if you're subtracting 2 is 1,992 recursions.
Yeah, but why? Like, why is this a problem?
A problem because it starts using too much memory, and for each call, it's calling every previous call as well. So
Okay, so it's using too much. So why is this using too much memory?
Is it because the stack's getting too big?
Yes. So each time you call the function recursively, it's adding something to the stack. So if you let this go, you know, if you had a huge recursion problem, in theory, you would just run out of memory because you would just create too many things in the stack, and each thing in the stack, you know, it takes up memory, right? It has to store information about variables and blah blah blah. So that's the problem. You're just creating, you know, you're creating a whole bunch of these objects, and eventually you could run out of memory. If you languages like Haskell, which is a functional programming language, and there are other like language that I often use at work called Scala. It has this tail call optimization, and it basically the compiler will turn your functional code into essentially a while loop. So it will reuse the same stack. So you don't run into that issue where it's creating, you know, stack after stack after stack.
Is that the same thing as memoization?
It's not the same thing, but it, you know, it's so memoization is like caching. You're basically storing the result, and there are cases. In this case, memoization wouldn't really help, but there are certain recursion problems where memoization would help. So memoization is basically storing the result of a previous computation, so you don't have to redo the computation.
When you said for this case it wouldn't work, is that because this isn't dynamic?
I don't know if I would say it's because it's not dynamic, but it doesn't. So if you have, for example, like what's a good one? Not factorial, but the Fibonacci sequence. So Fibonacci sequence could also be solved recursively, but in that case, you actually need to make two recursive function calls in the return statement. So it creates this huge branching tree of recursive calls, and the same calls are getting made over and over and over and over. So it just it expands out in this huge tree essentially. And so if you use memoization for something like that, then you can store those results and not have to make those function calls.
So you're storing the left and the right, and then it's recursively calling on what was stored.
You would you could avoid making the function call. So just a real quick, yeah, I don't want to get too off track.
Sorry.
So let me I'll just demonstrate a simple like memoization thing, for example. So this would actually be something that you could implement using a decorator. But for now, I'll just use a global variable just as a simple example. So if you want to memoize or cache results, what you would do is you would store the result of previous calculations here. So the first thing you do is you would check, you'll check the cache. So if so I'll explain this in a sec here. So result equals A plus B, and then I need to add this to the cache. So cache A B result. Okay, so now if I call this, so I have 1 equals add 1, 2, add 2 equals add 2, 3, and then add 3 equals add, and I'll do 1 and 2 again. And then I'll print, add 1, add 2, add 3. So no surprises, it works, but how do we know that it's actually doing this? So let's add a print statement here. Print and I'll show that full value. So a so the first time that this is called with 1, 2, this function gets called, it checks our cache. Is it there? No, so it hits this. And we can pretend that this is some very intensive calculation. It's just adding, but we can pretend that it's some very expensive kind of calculation that we don't want to just do over and over again. So once we calculate it, we save it here, and then we return it. And then the next time this gets called, right here, it checks the cache and sees that, oh, it's there, it exists in the cache. And so I can just return it directly instead of having to do this, in theory, very expensive calculation.
Very helpful, thanks.
You could also implement this pattern as a decorator. So if anyone wants to do that, you can share your solution with the class, maybe this afternoon. All right. Okay, so why don't we let's take a 5-minute break, and we'll come back and do some more recursive stuff. All right. All right, so let's move on to another example here. So what we want to do now is we'll write a function that will give us the largest element in a list. So if we're given a list of integers, we want to return whatever the largest integer is. So we can write that here. So def get max is going to take a list of integers. So I'll call it nums. And I'll use, this is totally optional, but I'm just going to use the type ints. So list of int. So that's what we're expecting. And this is going to return an int. Absolutely do not have to use any of this stuff. And if it's confusing, just ignore it. But the parameter is nums. It's a list of integers. That's what we're expecting. And it should return an int. All right, so I'm going to go ahead and I'm just going to write some tests right off the bat. And then we'll talk about how we can actually solve this. So I'm going to write test max.py and import unit test and create a class. So we test max, and it's going to inherit from, we'll talk about inheritance later this next week. Unit test case. That's how we're getting all of this magic stuff, because we're inheriting, we're basically borrowing a bunch of other stuff that exists in the code. And def test. So let's think about simple test cases. So what's the simplest test case? What's the simplest kind of input we could have?
You have a list of one integer.
Okay, good. So test max. Let's call it the length of 1. So self. And we're going to do input. Nine, and then we're gonna have to import our code. So from get max import, what did I call this? Get max. So self dot assert equal, and we'll call get max with the input, and we're expecting what?
9.
Okay, so let's add the boilerplate here. If name equals all right, so I'm going to run this test. So Python test max, and the test fails. Okay, so we've got some basic scaffolding set up. Now let's look at the problem. So obviously we're going to have to do this recursively. So what are the two things that every recursive function is going to have?
Base case and
Base-
recursive case.
Exactly. So we can comment base case, whatever that is, and then recursive case. All right. So we kind of have figured out what the base case might be with the unit test, but what is the simplest possible case here?
If length equals 1.
Yeah. So the trivially true base case, which is what the base case should be, is if the list has a length of 1. So if len, what do they call this? Nums. Return what?
The first element in the
Yeah.
array or
Okay.
list.
Else, well, we're not quite sure. But let's run our unit test now. And that test passes. Okay. So now let's try another test case with 2 elements. Let's do 1, 9. If we run this, the test fails, which is what we're expecting. Okay. So let's maybe go over here and think about, so if we have a list with 2 elements now, we'll do 1 and 9. What do we have to do? So we know we know in general that so what are the things that the recursive case has to do? Aside from this particular problem, what are the things that the recursive case is going to have to do?
It'll have to approach the base case in some way.
Yes. So we know that it's going to have to, let's see, break, let's see, get input closer to base case, and then it's going to have to do what?
Return recursively.
Yeah. So depending on what you're doing, you don't always have to return, but in this case, we do want to return. So we know we're going to have to do these 2 things. We're somehow, and if we're given a list with 2 elements and our base case is a list with 1 element, what's the, in general, what do we know about what this case is gonna have to do?
It's gonna have to get smaller.
Yeah, exactly. So make smaller list. So we know this. So we're just kind of incrementally thinking about the problem, getting more, a little bit more information. So hopefully it makes it less overwhelming. Okay. So we have to make a smaller list, and we're gonna have to recurse, and we're gonna have to call this function with the smaller list. Okay, so now if we go back here, if we're given a list of 2 elements, the base case is not going to hit, so it's going to fall through. So we somehow have to take this list of 2 elements and make it smaller. So if this is the example, and we want to get the maximum number, and we need to get rid of at least one, maybe we can get rid of a whole bunch, I don't know, but we have to get rid of at least one of these, right?
You do like a if less than and then a pop.
Okay, so we can compare the first and second elements of this list, and the one that's smaller, we know that that can't possibly be the maximum of the whole list, right? So we need to get rid of something, so we should probably get rid of that. So we'll compare first and second elements, and let's say remove the smaller one. Yeah, I'll just say lesser, so we don't use lesser one. Okay, so let's do that. So if nums 0 is less than nums 1, what should we do?
Return the function call equal to the greater number. So
Okay,
Yeah.
so we could return get max, and what are we gonna pass in as a parameter?
it's gonna be a list, and it'd be n nums 1.
So nums 1. So what is the type of nums 1?
Right there, it's gonna be an integer, but it needs to be a list.
Yes, so it has to be a list of integers.
Put a colon after the 1.
Okay, so tell me what this is doing.
That'll return a slice of nums starting at index 1, and then ending at the end of the list.
Right. So this is Python syntax where basically we have a list of a bunch of, we don't know how many elements are in it. Could be 2, it could be 2000. And we're saying cut off the first one, start from index 1, so remove index 0, and give me all the rest of the list. So that's what this is doing. Start at 1 and go all the way. If you don't pass in a second number, it will default to the end. Okay, so if the 0th element in the list is smaller than the first index element, then we know that this one can't possibly be the max. So we're going to get rid of it and call this again. So let's test. So our test passes. Okay, cool. So we're done, right? We wrote some tests and we wrote a recursive function and it passes the test. Let's write some more tests. Just to be sure. And then we got 3. We'll jump up to 4 elements. 1, 2, 3. And let's see if these tests pass. Awesome. So these tests pass.
These tests only pass if it's if the largest is at the end of the array.
Okay. Yeah, so we could keep writing more tests, but if we're not really thinking carefully about the tests we're writing, we might end up fooling ourselves. So what are some different kinds of inputs that we might want to check to make sure that our solution is actually robust?
Put the largest number somewhere else in the list
Okay.
in the end.
Okay. Let's try. Line, comma, 1. Self dot asserts equal. And then get max input, and we're expecting 9. We'll run this, and we get a failure. And which test failed?
Third test.
Yeah, so the output of, it's one of the reasons why, it's nice to use libraries like this. So you can see that this test failed, and it tells us why it failed, because none does not equal 9. Why is it none? Why, if I pass in 9, 1, does this return none? It's not supposed to return none, it's supposed to return int.
Nothing's getting returned because you're never checking. You just basically under line 11, we just got to do an else and then reverse if nums 0 is greater than nums 1, because we're never checking for that.
Okay. So what are we going to return in this case?
I don't know how to do it with slicing, but I would just do a returns and then the list dot remove, or dot remove the smaller one. I'm sure you can do it with slicing though, but
Okay, yeah. So I mean, there are a few different ways that we could do this, but yeah. So for now, we can just remove the second, or index 1. So let's do nums dot pop, and we can pass in an index to pop. So we'll remove the first one, the first index, and then return get max. And what are we going to return?
nums.
Yeah. All right, so let's see if these tests pass. They do. So let's do another test case. In this case, we'll just have mixed. Okay. Okay, cool. So I ran 5 tests. Yeah. Okay, so does this look good to people?
We're still not accounting for 2 of the same. So
Okay,
if
good.
9's in there twice.
Good, exactly. So that's a good case that we want to cover, right? What if the list is, For example. What if it's all nines? Yes, that would be, or let's just say duplicate. So what's the problem here? So first off, which test is failing?
The last one you just wrote.
Yeah, so this one is failing. And what it says none does not equal 9. So what's happening here?
Neither of those last two statements are evaluating the true, and so the return functions aren't being called.
Yes, yeah.
So we need another elif statement, or an elif statement that would
Okay.
pop one of the duplicate numbers off.
Okay, so let's say I pass in a list of, can we break this? Can we make this test fail with the simpler input? What's the minimum that we need to make this test fail?
Just to send in
reproduce
two
this bug?
nines.
Yeah, okay. So let's do that one first instead. So when you're trying to reproduce bugs, it's a good idea to try to break things down into the absolute simplest possible thing. So 2. Okay, so this still fails. So the 1 and the 4 are not really relevant to this particular issue. So 9, 9. So Matt, can you walk me through what happens when I pass in 9, 9?
Line 5's going to be false, and so it'll go to line 7.
Okay.
Line 10 will be false, and 12 will be false, and so it'll just return none.
Okay. So num 0 is 9, num 1 is 9. They're equal. So how could we fix this bug?
Another elif statement.
Okay.
Nums 0 equals nums x1.
Then what do we want to do here?
Pop num 0 or 1.
Yeah, so we could really do either one. So we could definitely add a third conditional here and handle the equals, and then we could just make an arbitrary decision about removing the first or second element, or we could maybe do something that's less than or equal. Forget which order. So let's try it like this. So either way should work. So that passes. Let's add the other one back in. Okay. So this is why you write tests. And if we hadn't written all these tests out and instead we're just manually running one at a time, this kind of stuff is much harder to see. All right. So let's say we can be we'll stop writing tests for now. I think that this is good enough. So here's our solution now. So we figured out what the base case, if we're given a list of ints, we want to get the max. The simplest possible trivially true example is a list of one element. A list of one element, that element is always going to be the greatest, just by definition. If the list has more than one, it could have 1,000 elements, it could have 2 elements, doesn't matter. If it has more than one, we're gonna break down the problem into, again, it's basically the simplest possible case. We're gonna look at this sublist and compare these two. If the smaller one we want to get rid of and return that new list, which brings us closer to the base case. So that's the basic idea is we're breaking this problem into the smallest possible subproblems and just repeating that over and over and over again. Okay, any questions about that? Okay, so now let's take it up one more notch. So we'll actually use the get max function. But what I want to do is implement bubble sort recursively. So if I have a list of elements, if I have a list of elements and I want to sort this list, so I want to return a sorted list. Have you guys looked at? I think we've had bubble sort as one of the challenges. Is that? So it's, there are lots of sorting algorithms, and sorting is kind of its own little niche. But bubble sort is a good one to be familiar with. And can anyone tell me how bubble sort works?
Checks current and next, and whichever one is, depending on how you're trying to sort it, whichever one needs to be swapped, you switch the indexes.
Okay.
Then you go to the next index.
Okay. So it basically will start by looking at this list and then comparing pairs. So is 3 bigger than 9? If it is, then you move it over here. Basically, yeah, you can swap it out. And then we move on to the next pair. And in this case, 9 is bigger, so we leave it there. We move on to the next pair. Is 9 bigger than 5? Yes. So we're gonna swap it out. And we move on to the next pair. Is 9 bigger than 7? If yes, then we swap it out. And we do that, and then you have to make multiple passes, but that's the basic idea. So you see that 9 started over here and it kind of bubbles up. And if we add this in a slightly different order as well, you compare these, it's fine. You compare these. Well, let's do something like this. So you compare these, it's fine. You compare this, it moves it up. You compare this, so you leave it, and then you make another pass. Is this bigger than this? Yes, and so on. So that's the idea. You're basically like moving, you're making multiple passes and you're moving the largest one up to the end of the list with every pass. So we can basically do this recursively using the maximum function that we have. So our output, we want it to be a new list where all the elements are sorted. So if that's our goal, how could we use the max function in order to do that?
Determine which one needs to be or is greatest, which needs to be moved.
Yeah. So we can take a look. So I'll just make a copy. So what's the biggest element in this list? So we can use our max function to do that, and we'll create a new list over here. Okay. And once we do that,
I have to remove it.
yeah. So we don't necessarily yeah, we don't need this element anymore. So what do we have to do next?
Loop through it again and append the next.
Yeah, so we're basically gonna repeatedly get the largest element of this list, and we're gonna make a copy of it, basically. Move it over here. And then what do we do here? We get the max of this list and put it over here. What do we do here? We get the max of this and put it over here. All right, so let's get the skeleton of this bubble sort written. So what is it going to take as a parameter?
A list.
Yeah. So nums, and we'll say list of int. And what is it going to return?
A new list.
Yeah. So it's also going to return a list of int.
Or a sorted list.
Yeah. Yeah, so it'll be sorted in terms of general types, though. It's going to take in a list of int and return a list of int. Okay. So what are the two things, without knowing anything about this problem, what are the two things we have to handle in a recursive solution?
Base case.
Yep. Base case. And let me call on who's being quiet. Sandy. What else do we need to do?
Recursive case.
Yep. Okay. Okay. So if we have a list of integers, actually I'm gonna go ahead and write some tests just so we can track this. So test bubble sort. Import unit test. Class. So can anyone tell me what a class is? We haven't gone over this officially. Just curious if anyone has any ideas.
An object type.
Okay.
So I
what's-
guess it would define the characteristics of an object that you're creating, essentially.
Yeah.
Yeah.
Mhm. Yeah, it's kind of like a template. If you need to create a bunch of things that are similar or have similar properties, you can create a template instead of manually creating new things every time. So we'll talk more about that next week. Def test. Let's see, test. So what's the simplest possible input we could have?
A list with one item.
Yeah. Okay. So test one. Okay.
That's the easiest test would be an empty array. That's more of an edge case.
Yeah. So that's kind of a question. I'll ignore that for now, but yeah, that's something you would also want to think about. What does it mean if you get an empty list, for example? It's a little tricky depending on what language you're working in, but we'll see if this works. So bubble sort input equals, it should be the same thing. We'll just do that, and then I'm going to run this. So Python test bubble sort, and we got an error here. So not actually do anything, so I'll just do pass. Test bubble sort. Oh yeah. Okay. So it didn't really run. This is the issue, and you'll probably experience that. I just did it. So you have to actually include the runner stuff at the bottom, or else the file it'll evaluate the file, but it's not actually going to run everything. So if name all right, so now I'll run this and it fails. It's missing one required cert equal, whoops. Okay, and we get none because we haven't implemented anything. All right, so what is the simplest possible case here?
When the length of the original list is empty or 0.
Okay, yeah, good. So, it depends on how exactly we're implementing this, but if let's say we're basically destroying the original list as we're creating the new one, then when there's nothing left in the original list, then we know that we're done. So in this case, yeah, I think that would be a good base case. So if len nums is 0, return what?
The new list that you're going to create.
Yes, so we have to have a new list somehow. So we'll just say new list. So we're not sure what that's gonna be right now, but we know that we're gonna have to return a new list. So else. So what do we have to do in the recursive case? So before we think about what specifically we have to do, what generally do we know we're gonna have to do in the recursive case?
Create a new list of sorted elements from the first.
Okay, yeah, so we're gonna have to create a list, a new list here. And what in general though, what does every base case, or sorry, what does every recursive case need to do?
Does it check current and next? Or evaluate current and next?
Okay, but we're not. I want to be more general here. So for any recursive problem, what do we have to do in the recursive case?
Get the input closer to the base case.
Exactly, yes. So we somehow need to get the input closer to the base case. And our base case is the length of this being 0. So somehow we're going to have to like remove something from this list. So I can just represent that for now as nums.pop. So this is just a placeholder, but we're gonna have to remove something from that list. Then what are we gonna have to do?
Append onto the new list.
Yeah, so in general though, we know we're gonna have to get this closer to the base case, and we're going to have to recurse. So we know we're gonna have to do something along these lines. Okay, so we have we've kind of put down everything that we know in general. So now let's actually figure out this particular solution. So we do have access to this get max. So I'm going to import that. So if we have, I'll comment these out for now. If we have a list of nums, we were looking here, we have a list. What we want to do is we want to get the maximum of whatever that list is, and then add that to a new list. Raymond, any ideas?
So if if the length is not zero and I'm sorry, can you repeat the question?
Yeah. So we're trying to figure out how we can implement part of this. So we have bubble sort. We know that our base case is if this the original input is 0, because we decided that, at least in this case, the algorithm is going to be take the input list, remove the maximum element, put it in a new list, and then we're going to have to go back and repeat the same procedure over and over again. So we know that we're going to have to get the maximum of whatever nums is.
Yep. So yeah, you would get a max, and then you would append it to a new array or something, and then
Okay.
well, first, I mean, so you get the max, and then you append that max, and then you do the nums pop.
Okay. So first off, we're going to get whatever the maximum of this is. Then we want to do this. So there are a couple ways we could handle this this new list that we want to create. For the sake of time, I'm going to go ahead and say we'll use a default parameter here. We can do new list, and we can set this equal to none. And then we can have a check here. So new list equals new list if new list, else we'll start with an empty list. So the first time we call it, new list is going to be none. So it'll become an empty list. So the first time we call it, new list will be an empty list. So what do we now want to do with new list? We have the max int of the original.
You need to push that max integer into the new list.
Okay. So let's do new list dot append max int. Okay. So we've created this, we have the max value, we add it to our new list, so that's good. So we now are basically doing this. So we now need to get closer to our base case, right?
So do we want to remove the 9?
Yeah. Yeah. So there are different ways we could do this, but yeah, for the sake of time, we'll just remove it. So we can do nums remove, we can pass in max int. So we found the max of the whatever the current list is. We've appended it to the new one, and we've removed it from the old one. So now what do we need to do?
Call the function again.
Yeah. So return bubble sort, and then what do we need to pass into bubble sort?
Nums in the new list.
Yeah. So nums new list. So this signature is I'm not marking this, but this would be called an optional type. So it could be none or it could be a list. Okay,
One really quick question. So
Yes.
if we didn't pass the new list when we are calling the function again, we would be rewriting that new list and restarting with an empty one. Is that correct?
yeah, exactly. So,
Okay.
let's try it without calling this. So this is an optional parameter. We don't have to take it. Let's see if our tests pass. So let's write the test. So that test still passes. And let me look at the bubble sort. So we pass in a list with a single element. That works. Let's add another test with 2 elements. Do 1, 9. And it's actually going to be the same. And that test also passes. So let's do a third one. Reversed. And that fails. So this test right here, test 2 len reversed. So this test fails. And what does it say? The lists differ. So an empty list does not equal 1, 9. So we're expecting 1, 9. This actually returns an empty list.
Wait, how did that second test pass if it never gets to the new list?
Yeah, that's a great question. So what's happening with this test? Let's walk through 1, 9. I'm gonna, let's see. Dylan, can you walk me through bubble sort with 1, 9?
Yeah, so it's looking like we would take 1, 9 as our list parameter, and then because so we didn't supply new list in the case of that call.
So let's pretend this is the first time we're calling it and we're passing it. Nums is a list of 1, 9.
Oh, okay, gotcha. So then we're gonna say not equal to 0. So we're gonna go to our recursive case. We're gonna
let's go line by line. So what is new list going to be?
In this case, just a blank.
So the first time we call it, nums is going to be 1, 9, and new list is going to be none.
So we just have a blank list.
Yes, yeah. So new list will be an empty list.
Yeah.
And we
yeah, I see it now.
And then so we don't hit our base case. So then we would call get max, which is going to return max int is going to be 9.
Yep.
So then we're going to append that to our new list. So that's going to consist of just 9 at this point.
Yep.
Our original list nums, we're going to remove 9. So that only has 1 in it.
Yep.
Then we recursively call bubble sort again with just a list of 1.
Right. So
which
now back up here.
Yep.
So nums is now 1, a list of 1, and new list is what?
We've defaulted back to none again because we didn't supply a parameter.
Exactly. So now new list is going to be an empty list. And we go through, that doesn't hit. We check. We add 1 to this empty list. We remove. So now nums is an empty list. We call it again. Nums is an empty list. New list is none. So now new list becomes an empty list. So now nums is an empty list and new list is an empty list. The base case hits and we return the empty list. All right, so we do need new list. All right, so let's run this now. Okay. So I have a little bit of an issue. So which test fails? It's the same test, but it's failing for a different reason. So this is returning just 9. So we walk through, so 9, 1. This is a new list, empty list. That doesn't hit. So no max int is going to be a 9. New list is going to now be a 9. We're going to remove 9. So now nums is a list of 1 and new list is a list of 9. So we're going to call this again. So new list is going to still be a list of 9. We're going to fall through this. The max of a list of 1 is 1. So we're going to append new list, which should be 9, 1, and we're going to remove the 1 from the old list. So nums should now be an empty list, and new list should be 9, 1. So here we hit the base case. So we should, I would expect 9, 1. Does anyone else see a problem?
I mean, I would expect the same thing, but if you only have one element in the list, do we want to append that? Do we want to set a condition for that?
Yeah, so let's, I think what we should do is use the debugger, because I'm expecting a certain kind of result and I'm not getting it, so I'm confused. So at this point, I think using the debugger would be a good idea. So I'm gonna, just so I can run this as a one-off thing, so if name equals main, I'm gonna call bubble sort, and I'm gonna pass it in 9, 1. And I'm gonna set a breakpoint. Just set it right here and run the debugger. Okay, so things I want to watch, I care about new list. And I care about nums. Okay, so now I'll go ahead and step in here. So the first time I call it, I'm expecting an empty list, and that's what it is. And nums has a length of 2, so that should not hit. Max int, I should step through this, but anyway, we'll just go through this process. Okay, so max int should be a 9, right? So the new list is still 0. Nums is now, let's see, right? Nums should be 1, right? Oh, never mind. Okay. So why is nums? Interesting. All right, let's keep going. So the new list makes sense. What is nums now? Why is nums an empty list?
Because you removed it.
But it started off as 1 or 9, 1. So 9, 1, and now it's just after the first call, it's
Was it removed when it went through the getMax method?
Well, so yeah, so that's a great point. So I have nums here, and what is getMax doing to nums?
It's paring it down all the way until it's one length.
Yeah. So what is this called? What is this kind of problem that we're experiencing?
Are you getting like a multiple recursion?
No. So
Is it a
what's happening?
subset?
So
You're doing a double remove. You're removing it in the getMax, and then you're removing it again in this function.
yeah. So we have this list, which is not a primitive type, and we're passing it around to different things, and this different thing is it's actually mutating nums, right? It's mutating nums. So this is one example of a side effect. And this is one reason people like to avoid side effects, because we have a situation where we've introduced a bug because our functions are not really pure, right? So we're calling another function that's doing something, it's mutating something else, and it's messing with our expectations here. So one thing we could do here is create a copy of nums. So nums copy rules n for n in nums. And let's see if we can do this. Let's get nums. Let's see if this works. I'm gonna stop this. And now we get the, so I'll talk about this in a second. This is running long, and I wasn't actually expecting this to happen. So yeah, I'll talk about this a little later. But for now, let's go ahead and fix the unit test here. So we're expecting 1,9, but we're actually getting 9,1. So the problem here is with append. So we're taking the max and we're putting it on the end, and we're taking the next one and we're putting it on the end. So we're actually getting a reverse sorted list. So we can actually use insert instead of that, so it'll put it in the front. Let's see if this passes. So that passes. Let's write one more test, and then we'll take a break. So then let's do 4. Next, 9, 1, 10, 2, 1, 2, 9. And that passes. Okay, so because our code was working on some bad assumptions, and because of the data type, this is a list is a non-primitive data type. So when you can create multiple references to the same list, but if you change that original list, all of those references will still refer to that mutated list. So in order to get around that, we create a brand new copy, an actual copy, not just have multiple names reference one thing, but create a new copy and then use that. So this is a great example of a side effect and why you want to avoid side effects. So in functional programming, you actually are not allowed to mutate anything. This is one of the strictures, and this is exactly why. So functions are, in an ideal world, functions are completely closed little worlds, and they only have what you give them and then what they return. They don't interact with the outside world at all. If you pass in an object which something else can mutate, then you've broken that seal, right? Now it's what happens in the function is influenced by the things outside of it. Okay, I'm going to stop here.